Okay, we're live. Hello everyone. Let's see what we got today. All right, what do we got? What do we got? Erlang just trying to complete the space station program. Slow news day today. Terraform for Stripe. Rate hikes are affecting economy. Yeah. Dear God. Twitter blue for $8 a month. Honestly, I think this is a good move. I know Elon Musk decided to take over Twitter, and he actually went through with it. I think this is a good move. I think this is a good move for Twitter profitability. I think that people sorely underestimate the power of the blue check. If you want to get any kind of traction or whatsoever, that's like the first thing people look at. Do you have a check mark or not? And I think people are not willing to let that go. It's a really good move by Elon, I think. Let's see what else we got. Compression algorithm. Facebook has a hidden tool to delete your phone number, email. I would recommend people do that. Easy Post is hiring. Huh. Look, if anyone has any news or anything in tech that they want me to review, please please send it in the chat. I'd love to take a look at it. Android Studios code contains Easter egg inspection. Interesting. There's an inspection called code contains Easter egg. All right. An Easter egg is a code that's deliberately hidden in the code from potential users and even other developers. This lint check looks for code which looks like it may be hidden from sight. What the heck? How can it systematically detect an Easter egg? Hold on. That is really weird. Let's take a look. Let's take a look at this. From the implementation of this lint, we can see that it searches for some of the string. Oh. Wow. Okay. So it actually looks for some Unicode escape, and that would hide some of the code that's actually being sent. Now that's interesting. That is interesting. Unicode definitely has a really good way of screwing with people when it comes to like looking at why some code might not compile correctly. Supposedly it's correct to unescape these sequences before levying comments, but the syntax highlighting in Android Studio doesn't behave this way. Okay, what do you mean by that? Yeah. So here, like, if you were to look at this through a normal text editor, this Unicode stuff would actually just be straight up hidden from you, right? And so you wouldn't actually see all the shit in here, but the compiler would, because it does it by the bytecode. So you would not see this through Android Studio. So wait, does this mean that Unicode escapes aren't actually parsed and saved to string literal? Blah blah blah. Interesting. Okay. So it actually unclosed string literal. Interesting. Hold up. Maybe I'm not understanding this correctly, but it seems like it's just screwing around with Unicode actually causes a lot of compilation issues in Android Studio. Now that could be really abusable, but it's actually kind of interesting too. There's an inspection called code contains Easter egg. It turns out that this inspection is limited to a narrow definition of an Easter egg used in the code's inspection description. It finds a certain syntax of Java code that tries not to look like code, not features like a flight simulator hidden in a spreadsheet program. Okay, from the implementation of this lint, we can see it searches for the string inside of a comment. That's some escaped form of... Okay. Supposedly, it's correct to unescape these sequences before even lexing comments, but the syntax highlighting doesn't believe this way. Okay, this kind of going a little bit over my head. But let's look at the source code. See if we can make heads or tails of it. So so it looks like this is the code for the linter check comment, right? So it's gonna look for up until the last two characters. It will iterate. That's fine. I don't have a problem with this so far. And then it looks at the source character. If the previous character that it looked at is equal to double slash, then it enters this block. Otherwise, if the previous is S or T. What? Okay, so this is the only thing we're really looking at. If the character that is currently U or U, which stands for U, that's gonna be Unicode, right? And then if source matches the escape string or escape string length, then it's gonna actually use this Easter egg. Okay, so what is this escape string? So escape string is so this is what they're talking about here. Actually, if the code actually has a double comment and then is followed by this Unicode shit, then it actually prints out the Easter code. All right, that's fine. So it just looks for this. It just really looks for this shit here. But if that's the case, what's the point? Oh, this is the escape slash, yeah. Wait, it says single character backslash then you. Okay, I see. But then what's with the asterisk? Oh, no, it's looking for this backslash u. So whenever you see this is like Easter egg shit. Okay, got it. But then, okay, this is like Unicode version of hiding code, right? Okay. Interesting. Okay, either way, I think that the bottom line here is that if you want to hide your code from developers in this way, you can actually abuse this Unicode that actually comes in here. But this is interesting, honestly. I think this is a good exercise for anyone who is interested in how like your linters work, how code underneath the hood works. I would recommend people like go through this exercise of when they see like some interesting shit like this. Really just take 10 minutes to really look in the code and just kind of see what it's doing. Anyway, with that, let's actually bring on my client and see what's up. I got a good feeling about today, actually, guys. So, hopefully this can be like a positive stream. You know, we're on week 9, and he's gonna be doing his interview in like 1 or 2 weeks. I'm really hoping that he does really well here. All right, let's see. Let's wait for him to show up. Okay, he's here. Cool. Hey, hello.
Hello.
Hey, what's up?
Hey, man. How are you?
Hey, you doing good? How about yourself?
Good.
How'd your practice go this weekend?
It went well. I did the H-index problem. That's one of the first problems that EPI introduces you to. Yeah, so I was able to do that one. Because I remember a long time ago I did this problem and it was really hard, or because I didn't know like how to start it, right? So this time around I was able to get it. I also did one. I think it's in the sorting chapter. It's one of the hard problems, right? That one I didn't do so well on because it was pretty late when I started this, so I think that was my mistake. But yeah, it involves heavy array manipulation and swapping. This is an algorithm where you move. You have an array of objects, and then you want to place objects close to each other that have the same they have the same attribute, like age, for example. You have an array of student objects, right? You want to place all together all the items that are the same age. So,
got it. Okay, so actually, let's take a look at. Well, first, before we go for that, first, what did you feel like you struggled the most with? Was it just that problem, or was there a common theme in general?
No, I think no. I would say the dynamic programming problem, because I haven't done that in a while. That's where I struggled there.
Okay.
Because I haven't done these problems in a while, so yeah, that's where I struggled the most in the dynamic programming problems.
Okay, that's fine. I expect you to be a little bit rusty, but like the last problem you did for dynamic programming should have been pretty good, right? Okay, that's fine. I'm not too concerned about that. I understand it takes time to warm up for these, especially for a problem that you didn't do. I have no problem with that. But I'm looking for something that you felt like, hey, this is a problem that I should have done well on, but I didn't.
Okay. Yeah, I would say the one. Let me see. Let me see the row. I'm looking for the row.
Okay, yeah. Let me look at your practice diary.
Yeah, row 178.
Okay, row 178. What do we got? Okay. So the problem is partitioning and sorting an array with repeated entries. Got it. Let me crack open the book. Since I'm at home now, I can actually use the fucking book instead of some random one. All right, let's see. Okay. Suppose you need to reorder the elements of a very large array so that equal elements appear together. Okay, cool. You're given an array of student objects. Each student has an integer value age field. Treat it as a key. Rearrange the elements of the array so that the students of equal age appear together. All right. The order in which the different ages appear is not important. How would your solution change if the... Okay. So you have two questions here, right? One is the... first, get this array sorted by, in this case, age. But within, like, you know, AA or in BBB, the actual lexicon or whatever the order doesn't have to appear in the same order, right? So... And so there's two parts to the question. One, ignore that restriction, and second one, get that restriction in. So let's see how you handle it. Okay. So do you have the problem sheet that you use?
Yeah.
Okay.
Yeah, I'll send it on Zoom.
Okay, let me take a look. Cool. Let's take a look.
Let me see let me give you the page number here.
Okay, partitioning and sorted arrays. Okay, cool.
Yeah.
So you do an example. That's fine, just to make sure that you actually understand. So ordering within, like you said, A, B, B, B does not matter. Rearrange elements so that students of equal age appear together. How would it change if students appear to sort of follow? Okay, good. You partition that up. That's a good call out. Focus on one thing at a time. Sort the list by using age as a comparison. Okay, yeah. So n log n, fine. Yeah. So there's something more optimal. Good question. We don't need to have the elements in ascending order as long as they're together. So, okay, so then what you do, so then you break it down, merge sort, quick sort, okay. Hold up. Breaking it down, then merge and end time. So you're basically, for merge sort, you're reducing it down to basically the average amount of frequency. But it's still fundamentally n log n, just divided by that frequency.
Correct.
Got it, that's fine. And then the quick sort do left and right, does the element movement at order end time. Okay, so quick sorting appears to need to solve this element, gather all elements. This take end time. Okay, so in other words, I think you run through an array and make a counter. Output a list based on how many times based on the counter. Okay, so you're keep doing a frequency map. Run and make a counter.
Yeah. So up to this point, that's where the book says it's optimal, but then they say there's another optimal way, and that's doing the in-place swap, and that's where I didn't get.
Got it. Okay, yeah, because this frequency map, because you have order n, you said your order n runtime and order n space, right? Okay, so the only dimension I can see, you're not going to get past order n runtime because it's unsorted, and by nature you can only run log n on sorted array, right? So the only other thing is to be able to do it in place in constant space, I should say. So that's what makes sense. So let me see, is this thing after the triple backslash? Is that you or is that the book?
This is me.
Okay. So yeah, so you correctly called that out. That's fine. Make a counter, output to a new list, the value of the number of times it appears. Make this work in place since we're not dealing with numbers and dealing with a class. Optimize age, make a counter. Okay, I like the offset idea. Cycle sort, yeah, that's fine. Don't code. I like the expletive. Maybe don't do that in an actual interview, but okay.
Yeah.
As long as it helps you understand it, I don't care.
Yeah.
I don't want you to solve the problem correctly, but then fail hiring committee because they said you swear.
Oh yeah. That's one thing to keep in mind.
But it's fine. It's okay in practice, It's like when your parents tell you, "Hey, use a fork and knife when you're in public, but you can mash your face into the food if you want at dinner."
Yeah.
It's fine.
Okay, yeah.
I don't mind this. I think cycle sort. I think cycle sort is the right way to do it. It's just you're probably not used to it.
Yeah, exactly. Yeah.
So then I would say, does the book do this? Let me ask.
They do something similar, right? Like they grab so they have an offset array. Like first they do the count of how many times it appears,
Right.
and then that they do the offset. So they grab an element from the hash map, or not the hash map, from the frequency map, and then they'll move that to the counter that you have in your offset, right? And then they'll update that counter. So that then they'll just go and grab another element from the counter, and then they'll do the same thing again.
Interesting. So they still use a frequency map, but that still means it's order n time, right?
Yeah, and then space, right?
Is it still order? It's still order n space. So I'm not sure how that beats what you just suggested, because it seemed like your first optimal solution, the one you after you made the first revision, seems like it would still be optimal, right?
Yeah. Oh, yeah. Well, I compared the delta to the book and what they had, and they did the whole offset thing there.
Interesting.
Mm-hmm.
I'm gonna say that you got pretty far. Probably farther than I would have got, because, well, for one, I don't think I would have been able to do that, which is good. For you, like, as good for you. But I still think it's a little bit of a weird problem. So go ahead.
It's like a super optimal one here.
It's weird, but you followed the logic correctly, which I think is a good sign. That's all I cared about. After that, if you still kind of like screwed up or whatever, I'm not gonna nitpick on it. I think this would have required like at least some help from the interviewer.
Mm-hmm. Oh yeah.
Other than that, I think you went on the right path. That's the only thing I care about.
Okay.
So good. All right. Other than that, is there anything else that you had questions with?
I guess with the DP, just keep doing them, right? Because what I noticed from doing problems in the past, when they're building up the most optimal way, it's the bottom up, right?
Mm-hmm.
I noticed in these problems in the last chapter, there's different varieties of how they build up this array. So yeah, that kind of threw me off right there. Because in the previous problems that I remember from these Grokking chapters, they don't have for example, let me step back there.
Yep.
Let's say I have a string of length 3, right?
Uh-huh.
What these guys did in this problem, they add another entry in the very beginning, so it counts as the empty string there. So I guess it's just me not seeing those problems enough, right?
Yeah, I would say like dynamic programming is one of those things where you see enough problems like that. It boils down like really only 4 patterns, right? Like I said, the way to think about it is that you start with a decision tree, and then you can prune and cache some branches in the decision tree because they represent the same state.
Okay.
That's basically fundamentally what dynamic programming is, and then once you cache the state, you know what dimensions to cache along, and then you get to go from like the top-down solution to the bottom-up. That's really what it is. It just means convert from a decision tree to a 2D array or an array. Other than that, it's fine.
Okay.
Anyway, so yeah, I think you have a very good grasp on what needs to be done. So let's actually do a problem, and let's see where that lands us. I'm very curious now, because it definitely sounds like since last week you made a lot of improvement. I don't know if you've noticed it, but yeah, the way you talk and the way you are able to present the problems, it's much, much better. Big improvement.
Mm-hmm.
So let's see.
Cool.
Let's see if I can give you a decently interesting problem. Let's see. Trade postmortem. No, let's say crit. Let's see. I guess since I'm giving you so many problems, I have to kind of start repeating some, so we'll see. And let me know if it seems too familiar, but actually, I probably don't care that much.
Okay.
All right, let me quickly answer that one. There's one question in the stream I want to get to. Actually, before I start this one. T-Nice says, hey, Edward, was studying 14 to 16 hours a day be too much? Was laid off back in May and going to start studying now. 14 to 16 hours is a way too fucking much. I don't think you get quality practice after you hit 4 to 6 hours. After that, you're just not focused enough. But as long as you're hitting like 20, 30 hours a week, you're fine. I think 14 to 16 is just too much, because obviously not all of it's going to be focused. You cannot get as much quality practice more than 4 to 6 hours for most people. Even like top professional players, they burn out because they practice quality 12 hours a day. So I think 4 to 6 hours is pretty much it. 8 if you're super disciplined, but yeah. All right, let's see. All right, let's get going and let's start this problem. Start the timer. Problem sheet. Okay. So suppose I gave you a block of text and a set of strings. I want you to find me the shortest number of words in the block of text that contains this set of strings. So in this case, so suppose I gave you string 1, 2, 3, 4, 5, and the set is 2 and 4, right? Then the shortest string would be 2, 3, 4. But in these cases, let's suppose in the last case, I have 2, 1, 2, 3, 4, 5 as a string, right? And then my set is 2, 4, 5. Then the shortest string would be 2, 3, 4, 5. Does that make sense? Does it make sense?
Yeah.
Okay.
This one we did in a past stream. Yep. Okay, it's fine.
But the thing is, remember, I'm only concerned about clean logic unless you think it's going to be way too easy. If it's way too easy, then I can give you another problem.
Okay. Yeah. Let's do this one. Yep. Okay, so suppose I give you a block of text and a set of strings. I want you to find me the shortest number of words in the block and text that contains a set of strings. So here in this example, okay, I have 2 and 4. Okay, that's the shortest. Okay. Okay, so for this, what do you want me to return back? Do you want me to return like the length of like this would be length 3, right?
Mm-hmm.
Length 3.
I want you to return. Let's make it interesting. I want you to actually return to me the string itself.
Okay, so in this example, I would just do 2, 3, and 4, right?
Okay.
Is that what we expect there?
Yeah. So yeah, correct. I want you to return to me back the string itself.
Okay.
Yeah.
Okay, so that's interesting. Okay, so the shortest number of words, right? So the string length does not matter in here, in this case, right? Because it says I want you to find me the shortest number of words. Okay.
Well, it's intertwined, right? If you know what the string is, then you can calculate the length from that.
Mm-hmm. Right. So, I see what you mean. So, because then what's confusing me here, it says I want you to return me the shortest number of words, right?
Right.
But then you said you want the string length, right?
Well, no, I want the string itself, right? So, in other words, if in this last example, I have 2, 1, 2, 3, 4, 5. This block here, let me highlight it just for your sake. 2, 3, 4, 5 is the shortest string that contains all the words in this set. You know, the other option is for me to actually return the entire string, right? Because 2, 1, 2, 3, 4, 5 would also contain all the words in the set as well, but it's just not the shortest one.
Okay. And let me see. And is it safe to assume that it's a list, right? Like this, right? Safe to assume we can process the string this way?
Well, let's bring this to the real world and maybe it'll make it a little bit more interesting. Suppose that the context that we're working with is like if I'm looking in a book, right? And I'm looking for a sentence in that book that I know has those words, and I just need to find that, sentence or paragraph that has those words. That's the context of this problem. But let's start simple. That's kind of like where I want you to be heading towards.
Okay. Okay, so you want me to return the shortest string. What's tripping me up here is my input, right?
Yes.
What's my input gonna be? It's just gonna be like a sentence, like you said, like "Hello, world," right?
Yes. So yeah, let's start with that. Let's start with your input being a string.
Okay. And is it safe to assume that it's not gonna have like periods or punctuation?
So it may or may not have punctuations. I would say, given the context of the problem, let's suppose that you may have punctuation in there.
Okay. Okay, so okay.
Actually, you know what? Let's start simple, right? Let's say that there are no punctuations, but
Okay.
But imagine that eventually we will get there.
Okay. Okay. Let's see. Okay, so okay, I want to find the shortest number of words in the block of text that contains a set of strings. Okay. So if I understand the exact ask, right? It's gonna have my set, right? And let's say it's hello.
Okay.
That's just gonna return me here, right?
Yeah.
This is the shortest string, hello.
Mm-hmm.
Okay. So then what if I do Alice? I do set equals hello Bob and Alice, right? So then if I look at this example here, it's going to return me the entire string, right? Because that's what has all the words in the set, right? Because that's what we are looking for, right?
Correct.
Okay, so I need so I need to traverse the string and find all the required strings in the set. Once I have this, I can save the string length.
Mm-hmm.
Okay. So that handles my simple case. Now let's say it was like this, right?
Okay.
So I'm doing an example of when to shrink this, because that's where I'm going towards, is like a shrinking window. So okay, so let's say I had so initially this would be my first answer, right? This length here. So then I save this, right? Save this string length. Then I can ask myself, am I able to shrink my answer to get a shortest string? So from there, what I can do is, let me move this below. Yeah, so for here, as long as it's valid, I can keep shrinking, but I see that it fails here. Mm-hmm. Once I remove hello mm-hmm. from my set. Mm-hmm. So then I'll increase this, and then I have another valid set length. So then I can check if it matches I can check the string length, right? And if it's less than my current minimum, I can say that. Okay, mm-hmm. So I need to traverse a string, find all the required strings in the set. Once I have this, I can save the string length. Save it if it is less than your current string length, right? Mm-hmm. This will be like a max variable.
Sure.
Or no. Yeah, let me see. Not max. You want to find the min, right? Not max. Okay.
Yeah, I want to find the min, yes.
Yeah. Okay, so I'll traverse a string. Once I have this, I can save the string length. Save if it's less than the current string length. Okay. While your sliding window has all your required elements in the set, shrink. Okay. Shrink the left side. Okay, so here I'll shrink the window, right? Mm-hmm. Shrink the left side. Okay, this will be like a while loop, and here I'll save to the min if say to the min if we have all the required characters, right?
Okay.
But this is repetitive here, right? In this idea above.
Okay. What do you mean repetitive?
So, sorry, go ahead.
What do you mean repetitive?
This right here, it's the same thing as here.
Sure.
So what I can do is I can incorporate this into a single loop, right?
Okay.
Like, yeah, let me say that into loop. So, okay. So while your sliding window has all the required elements in the set, and what else? Save the minimum, shrink the left side, right?
Okay.
So, okay, so here before I go forward, I want to see that. I want to see if I'm missing anything else, right? Sure. While your sliding window has all your required elements in the set.
I think there is an obvious question of how you're going to traverse the string first. Because it's going to seem a little bit complicated, right?
Okay, yeah. Okay, so first string. What I can do is I can split on the empty space, right?
Sure.
This is assuming a very simple example, right?
Yep.
So this is gonna return me a list of words.
Okay.
So it's gonna be like hello, Bob, Alice, right?
Yeah. You can assume that you have access to the Python split.
Okay. Okay, so I'll traverse a string and find all the required strings in the set. Once I have this, I can save the string length. Okay, so here. Okay, so let's say it's a current word, right? Okay, so now what I have to do is I have to get into the logic that says, talk about logic that. Okay, no. So what I have to do here is what do I do when I encountered a? What do I do when I encounter a word in the required set, right? So, okay. So, okay. What do I do when I require?
Right.
So my first thought here. Go ahead.
So I'm saying that, yeah, if we go back to your example, right? You're basically in a situation where you have, like this situation going on, right? So yeah, that's what are you gonna do?
Okay, so for that case, okay, so my first case is to do like a frequency map.
Okay. Of
my required set, right? So then it'll be hello, it's 1. Bob is 1. Alice is 1, right?
Okay.
A thing about that is that we're gonna allow I should have clarified this earlier. We're gonna allow like Alice multiple times, right?
Yep.
Okay, cool. So repeated elements. Okay, so my first thing is to make a frequency map of the required set, right?
Okay.
As I traverse, I will decrement these values from the hash map, from the frequency map.
Okay.
So that. Okay. As I traverse, I'll decrement these values from the hash map. Okay. Now I'm thinking, what? Oh no, this. Okay. Oh man. This is not a set, right? Because you can allow multiple words.
Okay.
Okay, so my word list is going to have multiple elements. Then I'll build a frequency map of the required set, right?
Wait. So is this the frequency map of the word list, or is this the frequency map of the string? I'm kind of confused now.
This will be the frequency of the word list. Okay.
Okay. For
Okay.
now, you can assume that there are no duplicates. Let's start there.
Okay. 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 So. Okay. Yeah. If there's no duplicates, I guess I'll use a frequency map. Because I have the number of required characters, right? I need like a number of required words, right, to match. Once a word in your frequency map reaches 0, you will increment the words matched, right?
Sure.
Okay. So I have the number of required words to match, right? This is a length of word list, right? Okay. Once the word in the frequency map reaches 0, you increment the words matched. Okay. So I see where I'm going here. Once a word in your frequency map reaches 0, you will increment the words matched.
Okay, so once your frequency, you increment the words matched. What do you mean? What do you mean increment the words matched?
So,
what does this mean?
So what that means is I have words matched in window string, right?
Okay.
And then I have okay. And then I have number of required words to match, right? Once this is equal, that tells me that this is a valid window string, right? This above tells me I have a valid window string.
Sure.
Okay. Okay. Cool. Okay. So going back to my example, let's say hello and Alice are part of my word list, right? Okay, so I'm just doing an example of what happens when I go in and out of a word here. So let's say I'm starting at hello. The frequency map, let's see, hello, it's 1. Then it's Alice, it's 1, right?
Okay.
So I see hello as part of my example here, my required words, right?
Okay.
So I'll decrement that to 0, right?
Okay.
I still don't have a valid window string, so I'll keep increasing my my pointer, right?
Okay.
Okay. So I see that I have Alice now.
Okay.
So up above here, this is gonna be words matched equals 1, right? Since hello went to 0, and then here after doing the second iteration to Alice,
okay,
words matched equals 2 since Alice goes to 0, right? In frequency map. Okay, so then I have words matched equals required words. So then I'll save the string length, right? Okay. So then I save the string length. Okay, so I save the string length, and then going back to the while loop I described below, right? So it's gonna be like it's just a quick example. While words match equals required words, save the string length, and then you shrink your window. So increment the left pointer.
Okay.
This will remove the left word. It will increment the frequency map if the word is in the required set.
Okay.
Okay. Okay, so here I'm thinking like here we're at hello, right?
Mm-hmm.
What's gonna happen when you increment this, right?
Okay.
Hello is gonna go back to 1, right? Your
Hello's
words
gonna go to
matches
0, isn't it? You just said if your string starts and ends at Alice, how many times does hello appear? What are you saying that this is a frequency map of how many elements are in your string or how many elements you need?
How many elements I need?
Okay.
Okay, so yeah. So initially the frequency map is gonna start with how many I need. So
okay. Again, I just assume for now that the initial string has no dupes.
Okay.
I mentioned that before.
Okay. Okay, so once we move over to Alice, we increment hello again, right? Because we unmatched it, so we have to increment that, and it's also in one of the words that we're looking for.
Okay.
Words match is gonna go back up to words match is gonna go from 2 to 1, right?
Okay.
Okay. Also, decrement words matched, right?
Okay.
Okay. Okay, so here, let me see.
Okay, I think your idea works, but there's also a level of inefficiency to it. What is that? I think you can get a little bit faster.
Okay. Okay, so how can I improve this, right? Oh, I see. I am keeping these words in a frequency map, right? Okay, so let's see how to improve, right?
Yes. I think you have the main idea down. It's just you can refine it a little bit more to get a little bit faster.
Okay. Okay, so I'm looking at the while loop, trying to see how can I improve this. I save the string length, increment the left pointer. This will. Okay, so while I have something that matches, I save the string length, then I increment the left pointer. I'm basically inserting and removing from the frequency map.
Yes.
Right? As I'm traversing this whole string. Yeah. The only thing that comes to mind is saving. Instead of doing a frequency map, what I'm thinking here is saving the position where these elements appear in my required words, right? So what I mean by that, because I remember we did this from a while ago. So
don't do it as if I told you the answer before. I want you to derive it as if we've never done the problem before.
Okay. Okay, so what is the most important thing in the string, right?
Where is okay? I see. Okay.
The words that I'm looking for. Okay. So what if you have a what if you store the indices of all your required words, right?
Okay.
Instead of having a hash map, instead of a frequency.
Okay. Why did you arrive at that idea?
The reason why I arrived at the idea, for example, Alice, this is not important, and Alice again, right? Mm-hmm. So the reason why I write that is you only care about the words that are in your frequency map.
Yes.
You're able to shrink these as long as you're not out of bounds. So for example, let's say Alice has a 0, right? Right. So Alice appears in 0, and she also appears in 5, right? Bob as well appears in 1, and yeah, he only appears in 1, right?
Okay.
So the shortest, because these are indices on your string, right?
Sure, I see your indices. Okay.
Mm-hmm. So if you're able to shrink these to find the shortest string that contains all these elements here, okay, that should give you the shortest string where all of them appear, right?
Okay. So I understand what you're saying, but your explanation was complete crap, by the way. So try to rephrase it. Just this is my words as a coach, but yeah. Mm-hmm, try to rephrase what you just said.
Okay. Okay, so what I'm going to do is I'm going to traverse this array. And at each index, if I find that word is one of the required words that I'm looking for, I'm going to save that index to a mapping of the word to the index, right? At the end, after I have all the indices that pertain to all the words I'm looking for, I'm gonna take the minimum element and the maximum element being the index in this case.
Okay.
So if I have my min and my max, right, I can determine the string's length that way.
Okay, you are hearing yourself, right?
Yeah.
Okay, I'm gonna give this one to you. Is that in the shortest string, if the strings and words that I'm looking at need to be the start and the end of my string. Any extraneous strings outside of that, like foo or bar, if I'm looking for Bob and Alice, outside of it, will immediately be pruned because it's a subset. Now, did you understand that idea when I said it?
Yeah.
You could have just done that. And this means, as a coach, you lost sight of the objective again. All I asked you to do was rephrase the idea and fundamentally, why does this idea work? But instead, you just went and reiterated your algorithm. So you lost sight of the objective.
Mm-hmm.
Okay, keep going.
Okay.
We'll talk more about it later. But yeah, okay. So now that you have that idea, now how does that affect the idea you proposed?
The one with the sliding window?
Yes, how does that affect your sliding window? Because you laid out this idea of, oh yeah, let's iterate through every single word, but you've just proposed to me the idea of, hey, we only need to look at the words in in the word list that I'm giving you. So how would you modify the idea you just proposed in order to do that?
Let me see. Wait. So I'm not understanding. Is this a question on how to improve my last solution? Or
no. I'm asking you. You gave me this all this word bar of your idea of how it's supposed to look, right?
Mm-hmm.
And now you're saying, oh yeah, now we need to just write. Now we just only have to look at each and every single index. So, how does your structure of your code change, or do you just want to write the code? Do you want to revise the idea that you've written here, or do you just want to write the code?
Yeah, I would have to revise this idea, right?
Okay.
Because it's going to change substantially, right? Because here I'm doing the whole sliding window approach. Whereas the other algorithm is just one pass on the array of words.
Okay.
So I need to traverse the word and find all the required strings. Once I have this, I can. Okay, no. So I'm gonna traverse a string and find all the required words in the set. Save word and the index, right?
Okay.
Okay. Yeah. Let me move this over because I'm gonna need this. So I saved in the word index. So what's my next step? I have all the words and the indices. Take the min and max. This will be your string length.
Okay.
So to do that, let's say it's 0, 1, 3. Yeah, I'm just throwing out some examples here to figure out how this would work exactly.
Okay.
So then if I do 2 and 3, right, this is another word that I'm looking for. Then if I do 5, for example, right? So, okay, so overall, the min is 0, right? The max is 5. Max is 5, okay? Okay, so how can I shrink this? So that's my next question, how to shrink and still keep a valid window. Okay. I'm gonna say if at any point you are index out of bounds, you no longer have a valid window. You can exit, right?
Okay.
So, okay, so now I'm thinking is like how I'm gonna increase the min and the max, right? No, increment the min, right?
Okay.
So
you say you only need to visit the indices of the words we're interested in. So.
Correct.
How does that combine with the idea of a frequency map and whatever?
So this example I just did like Alice, Bob, right? And let's say Joe, right?
Mm-hmm.
This is just to get a clear idea of how I would advance this. Okay. Why not? Why don't I shrink? Why don't I Okay, so let me increment the smallest.
Let me put a pause here because I want to point something out. What are you doing wrong right now? Let me. You've made this mistake for like probably you've been going down this road for 2-3 minutes. What is the mistake you're making right now? This is me speaking as a coach. What is the mistake you're making? And you made this before in the past.
Yeah, I'm trying to figure out here how to. Let me see. Yeah, I think I'm not properly explaining this.
No, it's you are going through the example again, but think about what the mistakes that you made in the past. This should jump out at you. And you're making this mistake again. If you need, go back to your prep doc. You should have a list of all the mistakes we've talked about. And go ahead, just go through each one of them. I put a pause on the timer, by the way, but yeah.
Okay. Yeah, don't confuse the fast answer for a good answer. What else? Yeah, are your tests simple?
Okay, yeah, that's fine. No, that's not what I'm concerned about.
Okay. Yeah, rambling, that's another one, another common one.
Rambling is a symptom. It's a symptom of a problem, but you have a bigger one.
Yeah, I don't think I didn't write down the idea properly for this.
Part of it, but more important, that's part of it. You are disorganized, but there's a bigger one.
Mm-hmm. Let's see what else. Yeah, it's like, do you understand what the problem is? Like that was one of the
I
main
think you
ones
understand
too.
what the problem is. At least I hope you do.
Yeah, yeah. Let me see. Yeah, man. Thinking back from my previous stream, I think I'm putting too much emphasis on this. I think I should have written down this more clearly
Part of
before I
it.
jumped into this example.
Part of it, yes. But I'll say it. You basically threw away your idea. So you remember we talked about this before. Hey, you already have an idea. We're just making one small modification to the iteration. And you now, because you made one small modification to the iteration, you feel the need to completely blow up the code. Does that make sense?
Yeah, I see where you're going there.
Yeah, you made this mistake before. The disorganization is part of it for sure. But more importantly, all you needed to do was just optimize one small part. It's not iterating through every single word anymore. All it is just iterating, is just trying to get the next word. Instead of going through every single word, you're just getting the next word we're interested in. That's it. We're just skipping some words.
Mm-hmm.
Why does it involve having to blow up your entire idea and start over if it's just one small modification like that? I don't know. You tell me. You tell me.
Yeah, it didn't click to me right away, right? Like, because my first instinct is to traverse this array like one by one, right?
Yes.
So yeah, just looking for the words that I'm interested in, that didn't click to me right away.
That's fine. It didn't click right away.
Because with the string, right, you still have to iterate all the words to find what you're looking for, right?
Yeah.
Because how could we possibly improve that? That's my
Sure.
That was my thinking there.
Sure, but the core idea is exactly the same, right?
Yeah.
All it is just changing the iteration.
Mm-hmm, mm-hmm.
So, you know what? I'm going to give you another 10 minutes. Let's see if you can code it out and save this, but I'll show you how straightforward it can be.
Yeah.
Go.
Okay.
Yeah, so feel free to code it out, do what you need to do, but I'm giving you 10 minutes to finish out the problem.
Okay, so going back to this example, I'm gonna increment the lowest value, right? I'm gonna increment that like if I'm at 0, then I'm gonna go to 1, right? Then I'm gonna compare the string length and say that if it's smaller. If I go back to 3, right, I see that there's something smaller there.
Okay.
So then my min becomes right here, right? So then I'm gonna have to do that string comparison again.
Okay.
Where I save the min length if it's smaller than what I currently have.
Okay.
Okay. Let's see. Okay, let me see. So going back to the idea where I was talking about this, yeah. So here, going back up, right? I have my while words match, right?
Mm-hmm.
Then I say the string length. So in this algorithm, you just, instead of having a frequency map, I'm gonna save the indices, right?
Sure.
So
Sure.
So let me see. Okay, so iterate over the string. If current word in entering the string, keeping an index. If current word is in required set required words, right?
Okay.
Save this to word indices, right? Word indices.
Okay.
Word indices. Save index. Okay, that's my simple n pass through the algorithm, right?
Okay.
So then I'm going to be left over with word indices, right? My goal now is to find the min and max, right?
Okay.
This will be your string length.
Mm-hmm.
You want to shrink to find a valid window.
Mm-hmm.
You will continue this until one of your lists goes out of bounds, right?
Okay.
Okay, so before I go into code, there's still one thing that's not apparent to me, right? Because you're going to have multiple lists. How do you find the min and max efficiently, right?
Okay.
Or multiple lists, right? I mean, let's say I have list 1, list 2, list 3. I mean, I can call max or min, right? But that's going to run in time. What else? If I make these, shit. Okay, damn it. Okay, now what I'm thinking here is like, what if you do a heap, right? But that entails you having a min and max heap for each list. That doesn't make sense, or at least it gets too complicated, right?
Okay.
Find min and max efficiently for multiple lists. Damn it. Find the mix. I mean, okay. For this first iteration, let's say I use a max for min, right? Then I will do that for all the lists. But how?
Let me know if you want to throw in the towel.
Yeah, it's fine now.
Okay. So, yeah. I would say the moment you failed was actually the moment you jumped straight to sliding window. Actually, now I would argue that's the point, because I think we talked about this in the past. When you don't do things from like the bottom up, build up your argument, you have this tendency of skipping steps. And I know I mentioned before, hey, you don't necessarily need to do this if you're very, very comfortable with it, but you're obviously not very comfortable with it. And so it's like kind of like, oh yeah, well, you need to review the sliding window. But instead of me just talking about like all the mistakes you made, let me do a compare and contrast. I'll do the problem in a logical way, and then let's see if you can begin to understand like the difference, right? So as a favor, I'll set the timer, right? And let's see how long it takes me to do it. I actually don't have the problem in front of me, the answer. I just have the fucking. I was gonna do it off the dome, but let's see how fast I should do it. All right, so the naive solution to this would just be, try every possible substring, with two loops, right? Nested loops, or I should say nested loops, right? So in other words, let's copy and paste the previous example, or the example I have here, right? So 2, 3, 4, 5, right? I would basically do something like try 2, 1. And then 2, 1, 2, 2, 1, 2, 3, 2, 1, 2, 4, 2, 1, 2, blah, 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 blah. You get the idea, right? And then move on to the next one, where I have 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 5. And then all I would do is after that check if run through the string, and then if all the elements in the set exist compared to like my candidate, right? And then, so to try to get possible substring, if the candidate string I have between the two pointers has all the elements in my set compared to the global candidate. If shorter than the global candidate, save the string. And then report back the global candidate. Something like this, right? But you instantly understand what this would look like.
Yeah.
Now, obviously, this is going to be n squared time, but it's going to be, what? It's going to be a constant space, because all I have to do is, like, save one string. I can make this even faster by, or I should say save space, by just having the start and end location, right? And then I can just take the difference of that in order to calculate the string length, right? And so this is like n squared, right? I need to get faster, right? So the next thing I would do is, okay, well, I would start with what's it called, sliding window, because that is the inefficiency here is I'm looking at strings repeatedly, right? So 2 1 2. So let's say I'm looking at 2 1 2, and then 1 2, right? These are substrings of each other. So if 1 2 happens to be in this case, or in this case of I'm looking at 1 2 3 4 5, this is a subset, and so because of this one is extraneous, I only really need to look at 2 3 4 5. So a sliding window would suggest, hey, yeah, let's start with the little bit more naive, right? So all I need to do is look at every single word in my sliding window. And once I have a situation where I have every single word in the set I'm interested in, and I decrease the frequency to, let's say, here, let me go a new line here. Then I will decrement this 2 frequency here by 1. And so this 1, 2, 3, 4, 5. Is this a smaller word? Yes. So I will just I can go ahead and use this. And then I'll shrink this again. Oh, 2, 3, 4, 5. Okay, is this smaller? Yes. And then I'll shrink 2. And then does this contain all the words in my set? No, because I'm going to go through my frequency map every single time. So I'm going to look at 2, 4, and 5. The moment that I have no existence of 2, I'm going to go backwards. And so I say the number of times 2 appears in my string, that doesn't exist. Then I'm going to just increase the right-hand pointer, right? So if I had to write this out, then let's say the first improvement, I would say get 2 pointers left and right hand side, and then populate. And then if the elements, let's say if the frequency map does not contain all the words in my set, increase the right hand side, right? And keep going. Else, if the frequency map does contain all the words in my set, check against the global candidate. If shorter than my global candidate, replace the global candidate, and then increment the left hand side and repeat this loop. So go back to here, you know?
Yeah.
So it does contain all the loops in the set, and then just keep going, increment left hand side, right? So this covers all of it. This covers exactly what I need to do. And of course I'm going to test this, right? But this is pretty much mostly correct, right? And so after that, the question now becomes, okay, well, the inefficiency here is, like I mentioned before, I'm just testing against subsets of subsets. So in other words, this 2, 1, 2, 3, 4, 5, I don't need to look at 1, because in the shortest string, I will never have a word that is not in my set be either the start or the end. So this 1, because it doesn't exist in my set, will never be the start or the end. So I can just, all I'm really interested in is the locations at which the elements are in my set. So 2, 1, 2, right? So I only need to look at 2. I only need to look at 2. I only need to look at 4, and I only look at 5, right? So in other words, I need to create a list of all the of the locations of my of my elements. So I can just create that, but then each time I'm going to need to replace it. So in other words, so I'm going to say at the beginning, create a array of all the indices of the elements in my set. So in this case, so using this example, I would say 2, 1, 2, 3, 4, 5. So then let's say I would need 0, 2, 4, 5, right? So the only thing I would need to do is iterate through this, right? And just create that, use that same exact logic here. So in other words, I'm going to start my pointers at left-hand side and then right-hand side. So then I think I'm comfortable with this enough that I can write the code, right? So let's say that my frequency map is I'll just do the code off the top of my noggin or some shit. I honestly don't really know how the fuck to write this, but so let's say frequency map is like this, right? And then I have left-hand side equals 0, right-hand side equals 0, right? And then for every element, let's say for int I equals 0, I less than let's say sentence dot length I plus plus or some shit like that. If sentence at I is in set, of course I'll fix this later, but I just want to get the idea down because I'm doing it off the top of my head. Frequency map of sentence dot I is plus plus or some, or just say frequency. Actually, no. I need to populate this, right? So actually, it's not frequency map just yet. I'm doing this population first. So actually, this would be let's call this IDX of set or some shit like this. So IDX of set would be a list, right? So then would just be dot add I. So let's start there, right? And so I have left-hand side, right-hand side pointer, right? The next thing would be, okay, I just need to iterate through all of this, right? So while let's say right-hand side is less than sentence.length, because all I need to do is really go through the length of the array, right? Per my idea up here. So let me copy and paste my idea here. So if frequency map does not contain all the words in my set, right? So if the frequency map, let's say check frequency map. Let's move this into another function, right? So if frequency map check, if it does contain, let's say if it does contain increase right hand side plus plus, and then frequency map of whatever is at sentence right hand side is going to be plus plus here as well, because I'm adding whatever the hell is in there, right? Or I should say right hand side, so right hand side plus plus, and I don't need sentence. I should actually say this is weird indirection here actually, so this is my fault. I should be referencing IDX of set actually, so for this right hand side. So I'm only interested in IDX of set for right hand side, right? And so here that's gonna be fine. Otherwise, if the frequency map, so I can just put an else here, right? Check against the global candidate. So then I have a global candidate. If global candidate, let's just say, let's say global candidate left hand side equals to 0, global candidate right hand side equals 0. So then if global candidate left hand side, else check against global candidate. If my right hand side is less than global candidate left, I should say right hand side less than left hand side, minus global hand side left hand side. So this is if the string is smaller, then just do the substitution, which is global candidate left hand side equals left hand side, and then ibid for global candidate right hand side equals to right hand side, something like that, right? Okay, so then now I have that. If it's shorter, then increment the left hand side, then increment the left hand side and repeat this loop, right? So then now I would need to increment the left hand side, which is so here, so left hand side plus plus, which means that, oh yeah, now that I've incremented the left hand side, I need to be able to take away the thing from the frequency map, right? So the frequency map of, let's say, of IDX, this indirection, this indirection is kind of killing me. I'm gonna clean this up, but I recognize this indirection is gonna be like a big pain in the ass here. So frequency map of this whatever is in the sentence, it's just go minus minus. So I'm gonna decrement that. Excuse this, and then left hand side plus plus, right? And now that left hand side plus plus is gonna go here, then I need to go back to this loop. So else, while else, and then I can just put this in here. While bang, let's say frequency map check, and I'll just put that here. So now the question, okay, now I'm going to start saying, oh yeah, well, I've kind of fucked up a frequency map check. So what does this exactly mean? Frequency map check, let me go back to my thing. If it does not contain all the words in my set. Okay, so then by definition, I've just said, hey, frequency map check returns true when, when I said here, returns true if frequency map does not contain all the words in my set. So, okay. So then this frequency map check, while true, so which means that if it's false, that means it does contain all the words in my set. So I can just keep doing this check over and over and over again. Right? Okay. So that's all my last part. And then now I'm going to say, let's say I exited this loop. Then return the sentence at the IDX of right-hand side. Let's say IDX left-hand side. Left-hand side to sentence IDX of set right-hand side. This indirection is going to kill me, but I'm going to clean it up. But yeah, this is basically roughly, I'll clean this code up. But now left is just frequency map check, right? So let me define this function here. Boolean frequency map check. So I'm going to iterate through the map. Let me pull up this definition again. So frequency map returns true if it does not iterate through the map. If any entry is 0, return false. Let's say return does not contain all the words in my set, right? So if it does not contain all the words in my set, return true. So which means that, hey, I'm missing some shit. Return true, else return false. So then iterate through the map. So I think in Java it's like while frequency map dot iter or some shit. Fuck. God, how do I iterate through a map again in fucking Java? Frequency map dot.
Can you do for each or no?
Can I? Or no, I do key set. Actually, I just do key set. So then while string s in frequency map dot key set frequency map of s. So if any entry is 0, so if frequency map dot s equals 0, return true, and then otherwise return false, something like this, right? And so now what are my issues? Well, the thing is that when I start this off, the frequency map's going to start off at 0, or right? So in other words, I need to be able to populate my frequency map at the beginning, so with 2, 4, and 5. So then for every element, for let's say string s in set, frequency map of s equals 0. So we explicitly call that out. So yeah, so basically I'm just kind of fucking around here, but notice here I got pretty far in this, right? So let me just double check. So frequency map to 0 for every sentence in the set. IDX of set dot add. We only care about the elements in our set here. And then while right hand side is less than sentence length, which means while we're not out of bounds, check the frequency map. Here, check frequency map. If we do not contain all the words in the set, then we increase the right hand side ++. Yeah, actually, I just realized there's a bug here where I need to add the, if I'm here, then I need to add the element of that set to the frequency map. So string and set, frequent, add that. So we initialize the frequency map, right? So the frequency map of right hand side, because they start at 0, right? So frequency map right hand side is equal to, is ++. Let's say set, but then there's that indirection I need to do, right? IDX of set. It's the map of IDX of set. IDX of set right hand side, and then sentence of whatever the word is. ++. And this is only if the sentence, yeah, if the end sentence is there. If sentence it does not length does not equal 0 or some shit like that. And so while the right hand side is less than the sentence not length, yeah. Check the frequency map. If the frequency map check, which is where we're iterating through all of it, then we're going to add the right hand, we're going to increment the right hand side, and then that indirection kicks in where we add the next element to the set, which is fine. So I'm gonna just do a quick mental test of this using this one because I think it's pretty comprehensive. But yeah, of course I'm cutting corners here. I could start a simple example here, but okay. So now I have that. So 2. So 2 2. Okay, so then the frequency map will contain 2. It has a frequency of 1, and then 1 here. So then it'll have 2 1. Doesn't have all that, but we still need 2 4 5. 2 now has plus plus because frequency. Where I define this shit? Yeah. So frequency map. Yeah. Okay. So we return true. So and then we're increase that. So there's 2 2s here. 4 is 0, 5 is 0. Blah blah blah. So it goes all the way here, right? And so now else the frequency map checks fails. So then else while this, so we recheck it. Sure. If the left-hand side minus right-hand side is less than the global candidate, which is 0, 0. Okay, I realize I fucked up because I set both those to 0. So which means that now I need to be able to, let's say right-hand side is in math.infinity. Because I need to make it infinitely large. So now I have right-hand side minus left-hand side. But I have the right idea here, so then we assigned 0 to 0, 1, 2, 3, 4, 5. Okay, that's fine. And then go to next one. And then we advanced the left-hand side pointer, which we decrease the frequency of with that right in direction. So this should be left-hand side. Left-hand side plus plus, which means that 2 now decreases to here. But because I already populated the IDX of set, so we need to go to the IDX of set, which is at 1 here. So 1, and then this one is actually at 4 because here. So then 1 to 4. Repeat this check here, which I think is pretty evident. Is 2, 1, 3, 4, 5. Okay, so now we go to 4. Boom, it fails that check. We go back to the top. Yeah, I think this is pretty much the right code. How long did that take me? 17 minutes. Okay, I expect let's double or triple it, just for the sake of argument. In other words, you should have basically gotten this answer in probably like 45, 50 minutes, I think.
Yeah.
And then of course like 10 minutes for discussion. But yeah, this is basically the way I would have done it. Now, I didn't do this to show off. I did this to show you, hey, all I did was really modify. I did the pseudocode, right? And I did here was do and you saw the evolution of the idea with 2 nested loops. I called out every single step here and I said what works, what doesn't. I kept this idea, I didn't keep this idea. And all I did here was define my conditions. And then I realized, wait a minute, it's too fucking hard for me to squeeze this all into one line. So I moved it to a function. Right? But I kept the core idea of everything that we talked about. And it's like very simple, right? Repeat this loop. And so take the delta. I want you to do this analysis. Do the delta between what I did and what you did.
Yeah.
I want you to walk that exercise. Where do you think we diverged?
I think as you were doing this, like right here where my cursor is, the index of
can
set,
you highlight it?
right?
I don't see it.
Oh, right here. Let me highlight it.
Okay, I think I see it. Yeah.
Yeah, I think when you were talking about going to something more optimal, it didn't click on me, or it didn't occur to me to only get the elements that we're finding, right?
Okay.
So yeah, this is an interesting idea, right? Because now that I think about it, if there's a million items, all your data, what if your data is like in the beginning and the end, right?
Yes.
With my idea that I have, I would have to go through all those elements and waste a lot of space, right?
Yes.
But then with this idea here, you only have the indices of what you want, or of your window, right? Mm-hmm. So yeah, that's where I see where it didn't occur to me, because you said to do something more optimal.
Yes.
So I think that's where I diverged. I couldn't think, and I don't know why I abandoned my idea. So I have to do some more thinking on there. Yeah, I'm gonna have to modify my checklist again and do the chapter on Grokking again for the sliding window.
Yeah.
Just to, yeah.
I mean, it's one of those things where if there's an idea that I've given you that doesn't click, then you need to fucking call that out. It's like, okay, I get where it's coming from. I get the optimization. But it's still like one of those things where it's like, okay, spend the time to fucking prove it to yourself. Tell the interviewer, give me 3 minutes 3 minutes to really
Okay.
prove that this idea works. That's fine. But when you just charge on ahead and you don't fully understand what the idea the interviewer is giving you, it gets really, really hairy and really quickly, and the interviewer can't keep up. I don't know, and so that's
Yeah.
kind of like where you begin to fall apart.
Okay.
I think
Okay, yeah,
I'm going to tell you like one of the verbal cues I noticed is that when you go, that should be that's your vocal tick for like, wait a minute, that should be a vocal tick like you're going to start veering off and not being clear on your objective. It's really
it's
important.
easy self-destructing, right?
Yeah,
So,
that's your vocal
yeah.
cue. I know, like,
okay.
I think like Jay had the problem. It's like but simply or some shit like that. That I can tell the vocal ticks and for you, your vocal tick is like when you sigh like that. You should instantly think,
Okay.
when that happens, you should instantly think, let me refocus myself. Let me focus on what is objective, what I know, what I don't know. It means that what is the thing? What is the most important thing? All right.
Okay.
We talked about this. In this case, it would have been, what do I understand? I understand what my naive solution is. What do I not understand? Why am I stuck? I am stuck because I don't understand what my interviewer gave me. That's perfectly fine. You could say something like, I understand the idea, but let me see how to incorporate this into my code. Okay, that's fine. Because, there's some linguistic barrier or whatever fuck. Or you could even say something like, what is the shortcoming of what you just said to me? What conditions does this not work? The interviewer would appreciate that. It's like, okay, maybe there's something the interviewer didn't think of. Like, hey, let me really, really test this idea. And I find that one of the best ways to understand an idea is to understand the idea when it doesn't work, not just like when it does work.
Right. Exactly.
So, I think anyway, that's something I noticed. But at no point did I really abandon my idea. I just kept the exact same idea. All I said is like, all I said was, okay, frequency map does contain all the words in my set. Increase the light hand side. Frequency map does not contain all the words in my set. And really, if you think about it, the only thing that really changed is this like tiny ass function that I put in here or whatever, right?
Yeah.
And all it is just like looking through the frequency map, and it's just doing this weird indirection from a set of IDX of set to not IDX of set. In fact, like even if I did come up with this idea, it would still be the same. All I would do is like, let's say I didn't come up with this IDX of set. I didn't make that jump, right? Let's say I took that out. Well, then IDX of set would just be all the code related to that would disappear, but the code would actually still be exactly the same.
Yeah.
And it would still work. So that's it. Nothing would have changed, right? The IDX of set just appears here. Let me highlight it in orange. Here, which is the initial population. But yeah, even if you yank those, the code still works.
Oh yeah. Of course, yeah. That's yeah.
Yeah. And then yeah. But notice that was just the difference. But it's a very small one, right? Like if you notice, like the fundamental idea is still exactly there. And that's why it's really, really important to get like each idea down, even if it's like the super naive one. Make sure you fully understand it, make sure it's fully bulletproof, and then build on top of it. Because really, when it comes to these optimizations, it's just one small thing like this. I mean, in a previous version of this problem, I think when I first did this problem, I think I came up with some really crazy 3-pointer endpointer map, right?
Yeah. It was like the you had multiple lists, right? And then you were comparing the min and max across all and shrinking those.
Yeah, that was probably like the first. That was like again off the top of my head, and this time I don't fucking remember. I don't even remember that when I was doing that problem.
Yeah.
And I was like, oh well, let me just build this up logically. I did it like basically differently, right?
Yeah, exactly.
I don't remember the fucking answers to these things. So it's like this one I just kind of did off the top of my head. And so again, I'm not trying to brag here. I'm just saying the only difference is that all I did was just take the idea that worked, improved it slightly. Took the idea that worked and improved it slightly.
Okay.
So that's really what I'm trying to get at here. If you just take like the few simple ideas. Oh shit, this is too hard. This is like let me move this somewhere else. I can write a simple for loop. I can check against global candidate. I know how to write these like little fucking small free wins. But checking the frequency map, I need to put that in a separate function because it's a little bit. It's not like 1 or 2 lines. It's like something a little bit more complicated. But the idea itself is very simple. So, yeah. That's really the best way I can describe it. Any questions about what you saw here?
No, man. I'm just gonna review this again and just trying to like hammer more array problems.
Mhm.
And first, I'm gonna analyze this, do the delta, and then revise my checklist again.
Mhm.
Because yeah, I really should put this at not to abandon my idea. Yeah, and then hammer away at array problems and the sliding window chapter here.
Part of it is also understanding yourself and knowing when you're in that, when you're about to make a mistake.
Like that good instinct that you said, yeah.
Yes. Like, listening to you, I mean, I'm obviously like watching replays, I'm watching you, your vocal tics, anything, any kind of sign, any kind of, it's like, part of it's like behavioral, right? Like, I'm looking at your behavior, what you talk about, where you go, why are you, like, what are like basically the moments before you're about to make the mistake, and what you tend to be prone to. Of course, like, there's a human element to it, right? But it's also like, once you understand and accept that, hey, you're just only human, and there are like certain patterns to the behavior, then you can understand when you're in danger of about to make a mistake. I can tell you, like, I've made these mistakes like many times. The only difference is that I'm very brutal about it, and just like, okay, these are like 5 different instances when I've made that little vocal tick or some shit I'm about to do that's gonna make me make a mistake. If you think about it in terms of like, don't make the mistake versus think about it in terms of, I'm about to make a mistake, here's the circumstances, here's like all this. If you can identify those factors, then it becomes instinctual of, okay, let me slow down, let me correct myself.
Okay, yeah. This is like writing into your diary entry, right? Like, so like I guess my question is like, what would be like something you would write yourself if you did this mistake? How would you incorporate that into your diary entry?
I would say, okay, I messed up because I got what's it called? Messy, right? The first thing I would notice if I was super naive about this and I saw this, I was like, oh, the first one is I'm messy. I wrote way too much compared to what Edward did, right? Edward really only took, let's compare like here, right? I only took let's say a page.
Yeah.
He came up with a naive idea, came up with the first improvement. In fact, he only went into this with the first improvement, and then decided, hey, there's a small optimization, but he didn't really fundamentally change the idea, right? This is like what I wrote. 1, 2, 3, 4, 5, 6, 7, 8, right? 8 lines, right? Let's compare it to what I wrote. I have all these examples. I kept doing the example over and over and over again, but was this necessary for me to do? Yeah, it was necessary for me to do that, but when I look at the code, I realize, oh shit, I take up twice as much space as Edward did. So it means that I need to be a little bit more organized about what I do. So I would move the examples to, the first thing I would do is like, okay, let me move I need these examples, so let me just move it to one separate space. And let me move the idea to another set space, right?
Okay.
You know, yeah, so you have these little tidbits of ideas. How to shrink and keep a valid window. If that point is indexed out of bounds, you no longer have a valid window, you can exit. Yeah, that's your exit condition, right? So what did Edward do here? It's like, okay, frequency map could just contain all the words in my set, else if frequency does not contain all the words in my set. Okay, so in other words, Edward made it implicit. He could have, Edward should have wrote this. This is a critique of the answer, right? Edward should have wrote what the exit condition is. That's fine. Okay. But then you also need to write that too. You need to be, it's like, that's like, oh, I would do what Edward does or what the answer does and improve it by being a little bit more explicit. But even then, it still wouldn't take that much, that much. So now because like, oh, well, I have this is what I'm doing right. I see that I mixed in an example and now like, oh shit, this is kind of, once I have this, I can save the string length. What do I do when I encounter the word in the current word? So it's like, okay, this is the part where I'm starting to not make sense. When your sliding window has all the required elements, shrink the left side. Yes, but what does this mean when all the sliding windows has your required element? So this is where it starts getting messy, right? Okay, so then this is like how I'm getting messy here. Okay, so now I realize, oh wait, I need to move so this goes back to the whole example thing. I need to move this outside the problem. So now the design needs to be in its own space. Now that I know that, I should now see, okay, what else did Edward do? Okay, he went pretty much top down. Either wrote what the exit condition is, if the frequency map does contain all the words it's set, if the frequency map does not contain all the words it's set. Okay, this is a binary event. I can just focus, he did this, so now I can focus on one element at a time instead of me trying to mush this all together. You see how this kind of blends in? But if I just separate it into branches and focus on one thing at a time, then I don't have to like fucking like merge all this crap together. So it goes back to a little bit of organization, but it also goes back to not segmenting the problem correctly.
Yeah.
So in other words, the lessons I would do here is like, okay, what else did I do here? Find min-max, that's fine. The basic idea, find min-max efficiently from multiple lists. Like If you store, what if you stored indices? Okay, that's fine. So frequency map, yeah, as I decrement defines it from the frequency map. Okay, so I'm still looking at this. I see all I have are a bunch of disorganized ideas. I need to be able to have a solid idea that I can grow in an area that I leave in an area that I leave for specifically for that idea. So yeah, this is basically the takeaway. I need to be able to keep the area in which I have my idea compact. I need to move the where I manipulate examples elsewhere. And then each part of the pseudocode or idea needs to be bulletproofed in and of itself.
Okay.
So once I say, hey, this one part, try every single assumption with 2 loops. I am not, this is something that should be plainly obvious, right? Da 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 da. Okay, now 2 pointers. And then so frequency map does contain all the words in a set, does not contain all the words in a set. What the exit condition is, increase right hand side. So yeah, I would say each idea in and of itself in this pseudocode can be isolated and examined. So this is the way I need to write my pseudocode.
Okay.
So this is like a very quick analysis, but this is like what I would do. And then I would try saying, hey, let me try this idea of segmenting out my idea and then taking each line as an idea in and of itself. And you notice there, I even screwed up some shit, right? Like I said, left-hand side, right-hand side equals 0. And then when I went to go test it, I'm like, oh shit, I fucked up. It's like, but I recognize each individual part is discrete. Like none of these really merge into each other, right? This is initialization. Initialization, right here. And then initialize the frequency map, initialize the IDX of the sets, etc., right? I'm just initializing all this crap. In fact, now that I look at this, I actually don't, I still need this actually, yeah, because otherwise I'm going to get a key issue actually. Yeah, I need this so that way I don't get like a key not found or whatever fuck it is. But Python would immediately return a 0, whatever. So check frequency map. So yeah. Yeah, and even when you notice when I wrote it, all I literally said, I just started by saying if frequency map check, else otherwise, right? And then just said, hey, yeah, if, and then just like copied each individual idea, and each idea was a singular idea.
Yeah.
That's it.
Okay.
So every single idea you write needs to be focused and disciplined. That's the best way I can describe it.
So this is like another section for test as well, right? Or where do you do that along with your samples? How would you organize that?
So this is more of an approach I would use rather than like let me make sure I do XYZ step. This is more of a stylistic thing where it's like instead of me trying to do 1800 steps, let me try being as efficient as simple as possible when I write my shit.
Okay.
It's like setting myself up. I use the thing of buying insurance instead of me trying to like make sure that every single time I'm at a stoplight I need to check my rear view mirror, side mirrors, etc. etc. Instead, why don't I just buy insurance and do the best I can? Make sure I have my seatbelt to begin with, and make sure I have the setup. That way, when I actually go and drive, I don't have to keep checking my seatbelt. That's the best way I can describe it. But yeah.
Okay, that makes sense.
Okay, I mean it's an abstract idea, and I don't think we're gonna get to a system design. So we can end early and we can do a system design on Thursday, but
okay. Sure.
Yeah, let's do that. But I think that again, you're copying the form of the approach, but not the function of it. I think that's the part we're really trying to get at. Like you're doing everything correct. Don't get me wrong. It's just that there needs to be a fluidity to it. And the reason why I think it's not fluid is part of it is that you're still hyper focused on the checklist. I want you to be free when you do these problems. I want you to really say, hey, this makes sense, does not make sense instinctually as a human being. It's like, if I threw the checklist in front of you, I have no doubt you would be able to do it. The only problem is that you're doing the checklist and it kind of also screws you up because it's not really natural to you. The checklist is more of a, hey, wait a minute, I'm fucking stuck. Am I doing something wrong? It's a It's a post-problem thing. You shouldn't be trying to hit the checklist while you're doing the problem because then you just end up going, am I doing this right? Am I doing this wrong? Blah, 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 back and forth.
Yeah, because when I'm doing these, that's what I'm doing is like actively thinking back to it. So yeah, that's a good point there.
Yeah. The thing is that when you do these problems, like, or any engineer is going to be like, going to miss some stuff, right? That's natural. But the checklist is there on the review. When you look back on your problem, and say, did I, at these steps, if I screwed up, did I do everything I could? And that's where the checklist comes in. But don't think about the checklist while you're doing the problem. Remember, it's a human being solving the problem, and you should be able to communicate like a human being. Does that make sense?
Yeah, that makes sense. Okay.
Okay, so let me paste the fucking notes here. And yeah, I think that we're at the stage like I know you can do it. It's just making you more human. If that's the best way I can describe it.
Yeah.
All right. So.
I had a quick question. So you said to do the EPI, the hard problems, right? And also DP. Do you suggest me doing that at the same time, or do DP first? What would you recommend there?
I would rather you do this first.
Okay. Sure. Sounds good.
Yeah, it's a very interesting situation I think you're in. This is like what I call I don't know if you know the term alpha and beta, like in terms of stock market valuation, but basically or stock market portfolio is basically like beta. It's like alpha is just how much advantage you have and whether or not and that comes from instinct, right? It comes from who you are. Now you can get alpha by like fucking research, practice, and whatever, but at some point there has to be some fluidity to it, and we're trying to make this fluid right now.
Yeah, that makes sense. Okay.
So this is let me. I'm trying to figure out how to get that on you, and it's like it's the last jump that no matter how much practice you get, it's either you get it or you don't. And people can fake it to get past the interviews. That's no problem. But
okay.
I'm trying to make it better for you. I know I'm kind of rambling here, but it's just like it's like trying to describe a new color to someone.
Yeah. Or what a fruit tastes like, right?
Yeah. So it's like it's hard for me to describe, but I'm trying to set you up. I know you can do it. It's just what does it take to make that jump?
Okay, yeah. So, I think not actively thinking of the checklist, that's my next step to do, right? Because for the past weeks, that's all I've been doing is like, am I doing the naive solution? Am I doing the ELI 5, etc.? Just actively thinking of this. So, I see what you mean there.
Yeah, fuck. I lost the goddamn tab. It's... I lost
it should be on the stream, right?
It should be on the stream,
I'll replay this. Yeah, I'll replay it. So.
Okay. Yeah. Either way, like I said, I know you can do it. But it just needs to be instinct. So. Okay.
Mm-hmm. Yeah.
Okay. Any final thoughts?
Cool. No, that's it for me.
Okay. Yeah. We'll do a system design interview on Thursday then.
Okay, sounds good. Do you want to replay for the no? Do you want to replay for the DSA or no?
I want you to do a replay analysis of this problem. I want you to actually once you do the step by step and incorporate it. And once you do a few problems after that, once you made the changes and try to make it instant, come back and do this problem. And then let me know how it goes.
Okay.
But I don't want you to regurgitate the things I say. I want it to be in your voice. It needs to be natural to you.
Okay. Sounds good.
Okay. All right,
cool.
Then
awesome.
I'll let you go.
Awesome. Thanks, man.
All right, take care. Bye-bye.
See ya.
All right, any final questions from the crowd? I know that I kind of rambled on that one, but it's like I know he can fucking do it. He does everything right. It's just making it instinct. So if there's anyone in the crowd who's just like, hey, yeah, this is too harsh, or hey, I don't understand what Edward did here, or you think I could have done something better, please let me know. If I were a senior in college grinding for coding interviews, how many hours would I study in a day, and how many breaks would I have in between what time intervals, assuming no school obligations? I would always try to have quality practice over quantity. Any hour I can spend doing quality practice, and as long as I'm, getting better, as long as my thinking is better, and as long as this is something I want to do and not like being sloppy about it, I'll keep spending those hours. I think that for people, bare minimum, if you have no school obligations and whatever, you should be putting at least 8 hours in. That's at least that's bare minimum, I think that even now, between my out of work shit, I easily spend like 4 to 6 hours on a day on it. So this would be like reading stock reports, reading whatever the fuck I get my hands on. And then on the weekends, I'll spend another 4 to 6 hours. So what? That's like 20, 25 hours a week working on non-work shit. So you can call it side hustle or whatever. But for someone who has no like work obligations and shit, I expect 40 minimum if you're disciplined. That is, maybe you're like a genius or some shit. I know Valid it's funny because I think Valid is actually smarter than me. Because he was able to do this with 15 hours a week while having a job and having a side business. That's shit I cannot fucking do. I'll straight up tell you. But he was able to pull like fucking senior engineer with 4 years of experience doing that. But it's that's the best way I can describe it. Is that you need to be disciplined enough to put in quality practice. Do you think studying questions by algorithm or approach? Do you think it's worth knowing how to solve a question in multiple methods, or knowing the only optimal solution is more important? You need to have a bulletproof approach. That's the best way I'll describe it. You basically every single question you do is meant to be able to train the framework that you have to approach any single problem. I think where people really screw up is that they just stop at EPI. Oh, let me memorize all these patterns. That's step one, is that you should recognize these patterns. Because after that, what comes is knowing how to apply those patterns. Step two is, I need to be able to look at a problem, analyze it, come up with a naive solution, recognize the conditions that I can use this pattern on, and then recognize my inefficiencies. That's EPI is just there to start that process for you. Sorry, grokking is there to start that process for you. After that, it's EPI. Maybe I am screwing up here because I recommend people start with. No. Maybe I need to reword it in my guide. But basically, everyone just says, "Oh, grokking, I'm done." No. There's way more to the guide. So maybe it's my fault. Maybe I'm not communicating the idea right. But I'm not quite sure. Anyway, I need to get something to eat. Thank you all for joining me, guys. We'll be back here Thursday, 8 p.m. Pacific Standard Time. If you guys want to be coached, you can book me for interview coaching at echandtech.com. Look in the description for my socials. I'm very active on Discord. You can message me, post problems, or have any career advice. I'll be happy to chat with you. Until then, thank you all for joining me, and I'll see y'all later.